In the silence of space, light is the only messenger that survives across billions of years. Each faint beam that reaches our telescopes carries with it a story from the earliest days of the cosmos. When the James Webb Space Telescope first opened its golden mirrors to the night sky, it was designed to capture these whispers of ancient time, light so old it has traveled since the birth of galaxies. But among the countless discoveries Webb has delivered, one stands apart, casting a long shadow across our understanding of the universe. What appeared on its detectors was not just another distant galaxy or a faint flicker of starlight. It was a giant and impossible presence. Buried in the farthest reaches of cosmic history was a black hole with the mass of 50 million suns, at a time when the universe itself was still young, barely beginning to form stars and galaxies. This monster was already there, sitting in the dark, defying every expectation. According to the rules of astrophysics, such a black hole should have taken billions of years to grow. It should have required countless stars collapsing, merging, and feeding the beast slowly over time. But here it was, fully formed, immense, and ancient, when the universe was still in its infancy. Astronomers stared at the data in disbelief, checking again and again for errors. Yet the numbers did not change. The evidence was clear, undeniable, and unsettling. Somehow, the cosmos had created a black hole that should not exist. And in that mystery lies a challenge not just to our models of black hole growth, but to the very story we tell about how the universe was built. The James Webb Space Telescope is not just another instrument floating in orbit. It is, in many ways, a time machine, an eye that lets us see the universe not as it is today, but as it was billions of years ago. By capturing light stretched and weakened over unimaginable distances, Webb gives humanity its closest look at the dawn of creation. Its golden mirrors were designed to do what no telescope before it could, to pierce the veil of cosmic dust, to peer deeper into the infrared spectrum, and to witness the birth of the very first stars and galaxies. Astronomers had theories about what Webb would uncover. They expected to see galaxies forming gradually, stars clustering together, and small black holes growing slowly in the shadows. These were thought to be the seeds of darkness, tiny black holes formed from the collapse of the first massive stars. In time, perhaps over billions of years, these seeds would feed, merge, and evolve into the supermassive black holes that anchor modern galaxies like the Milky Way. The process, though violent, was believed to be painfully slow. Before Webb, the Hubble Space Telescope gave us tantalizing glimpses of the early cosmos. Hubble revealed young galaxies glowing faintly in the distant night, their shapes irregular, chaotic, unfinished. But Hubble had limits. It could not see far enough into the infrared, nor could it cut through the thick curtains of gas and dust where the first cosmic structures were born. Webb, with its advanced instruments, was built to answer the questions Hubble could only raise. Yet when Webb's first deep-field images arrived, they carried more than beauty. They carried shock. Galaxies appeared more numerous, brighter, and more mature than theory predicted. And at the center of one of those galaxies, scientists found something staggering: a black hole far larger than anything that should have existed in that era. For decades, the prevailing models of cosmic growth told a neat, logical story. Black holes began as small, star-like remnants, and galaxies grew around them like slow-building cities. But Webb has forced astronomers to admit that this story may be incomplete. The discovery of a 50 million solar mass giant so early in cosmic history has shaken the foundations of these models. As one astrophysicist put it, with a mixture of awe and unease, "It's like finding a skyscraper in the middle of a village made of huts. It shouldn't be there, but it is." The question now was unavoidable. Had we misunderstood the pace of cosmic evolution all along, or was something even stranger at work in the depths of the early universe? The discovery was not a faint whisper, but a thunderclap across astronomy. In the depths of Webb's data lay the signature of a monster, a black hole with the mass of 50 million suns. Its age made the finding even more astonishing. It had formed just a few 100 million years after the Big Bang, when the universe was still a fraction of its current age. To scientists, it was like walking into the ruins of an ancient city and finding a skyscraper already towering over the skyline. Something about the timeline no longer added up. The key to this revelation lay in light itself. Every photon captured by Webb's mirrors had journeyed for billions of years, stretched along the way by the expansion of the universe. This stretching, called redshift, acts as a cosmic clock. The greater the redshift, the further back in time we are looking. Using precise spectroscopy, astronomers could decode the fingerprints left on this ancient light, signatures of gas swirling around the black hole, heating up as it fell into the abyss. The calculations pointed clearly to one conclusion. The central object was far too massive for its age. The rules of black hole growth say such giants should need time. Even the most efficient feeding, known as accretion, should take billions of years to reach this size. Stars would need to form, live out their lives, collapse, and merge into black holes. Gas would need to spiral inward, adding mass bit by bit. But in this case, time simply wasn't on the universe's side. The growth timeline failed, leaving astronomers facing an uncomfortable paradox. Either our models are incomplete, or nature has a faster, stranger way of building cosmic monsters. New theories rushed to the forefront. One suggests the direct collapse model, giant clouds of primordial gas collapsing under their own gravity into massive black holes right from the start, skipping the slow star formation stage. Another points to runaway accretion, in which early black holes may have feasted far more efficiently than previously believed, swallowing gas at rates that today seem impossible. A third possibility is that galaxy mergers, even in the young universe, accelerated the process, funneling vast amounts of material into central black holes and boosting their growth in cosmic leaps rather than slow steps. Yet each theory carries flaws. Direct collapse requires extremely rare conditions, the kind that may not have existed often enough to explain so many massive black holes. Runaway accretion risks breaking the known physics of radiation pressure, the limit that normally stops matter from falling in too quickly. And galaxy mergers, while powerful, may not have been common enough so soon after the Big Bang. Webb's evidence seems to push against all these explanations at once, leaving astronomers caught in a scientific crossroads. Some now turn to an invisible player in the cosmic drama, dark matter. Though unseen, it shapes the scaffolding of the universe, pulling ordinary matter into clumps where galaxies can form. If dark matter was denser or more structured in the early cosmos than models suggest, it could have acted as a gravitational shortcut, speeding up the growth of black holes. This possibility opens yet another frontier. Perhaps the strange behavior of these giants is not just about black holes, but about the fundamental architecture of the universe itself. The debates rage across conference halls and academic journals. One astrophysicist remarks, "Every explanation we propose feels like patching a hole in a dam. Fix one problem and another springs up." Others see this as a thrilling moment, a chance to rethink what we thought was settled. For the first time in decades, the basic assumptions about black hole evolution are on the table again. In the end, Webb's discovery forces us to consider a daring possibility, that the universe is rewriting its own rulebook before our eyes. What we thought were cosmic certainties may only be rough drafts. And somewhere in the dark, 50 million suns worth of gravity remind us that the story of creation is far stranger, faster and more unpredictable than we ever imagined. The discovery of a 50 million solar mass black hole in the universe's youth is not just a puzzle for astronomers. It is a direct challenge to the blueprint of cosmic evolution. For decades, scientists thought they understood the slow, careful architecture of the cosmos. Galaxies were to grow like ancient cities, brick by brick, with small stars and black holes gradually merging into the grand structures we see today. But this discovery has ripped holes in that narrative. If such giants existed when the universe was still only a few 100 million years old, then something about our map of cosmic history is fundamentally flawed. The implications stretch far beyond astronomy. At the heart of the mystery lies a bigger human question. How did complexity arise so quickly after the Big Bang? If black holes could grow at lightning speed, then galaxies may have matured earlier, stars may have ignited sooner, and perhaps even the building blocks of life had a head start. The early universe may not have been the quiet, simple place we imagined. It may have been a storm of rapid creation, a furnace that forged the ingredients for everything we know at a breathtaking pace. For the James Webb Space Telescope, this is a triumph. In just a short time, it has proven itself not merely as an extension of Hubble, but as a revolutionary window into the past. By catching the faint signals of galaxies and black holes that should have been invisible, Webb has shifted astronomy into a new era. Its success validates decades of work and billions of dollars invested, and it reminds humanity of the extraordinary power of curiosity turned into technology. But the triumph comes with pressure. Physics itself now stands in question. If black holes are appearing earlier and larger than the models allow, then perhaps our equations are incomplete. Could the laws of gravity behave differently under the extreme conditions of the infant universe? Are we missing new particles or forces that helped accelerate growth? Some scientists even wonder whether dark matter, still invisible and mysterious, holds the key to solving the puzzle. What was once theoretical speculation is now a pressing demand for answers. Within the scientific community, the discovery has sparked both awe and skepticism. Some researchers embrace it as a thrilling challenge, a chance to break free from old assumptions. Others urge caution, reminding us that extraordinary claims require extraordinary evidence. As one astrophysicist put it, it's either the most exciting discovery of the decade or the most carefully disguised error. The debate itself has become part of the story, showing science in motion, messy, human, yet relentlessly driven by curiosity. Beyond the conference halls and research papers, this discovery reaches into culture and imagination. It reminds us that the universe is not a finished story but an unfolding mystery. Every time we think we understand its rhythm, it shifts the tempo. For audiences around the world, the Webb's black hole discovery is not just about equations or redshifts. It is a reminder that the cosmos is alive with secrets, waiting to overturn our expectations, and that our place in it is still more mysterious than we dare believe. The enigma remains, a monster too soon, a black hole that should not exist. It challenges everything we thought we knew about the universe's infancy. And yet, perhaps that is the true nature of science, to confront the impossible, and in doing so, to expand the realm of the possible. This discovery is not an end, but a beginning. Each question it raises opens the door to 10 more. The existence of an ancient giant forces us to reconsider how matter gathered, how galaxies bloomed, and how the cosmic stage was set for life itself. In its shadow lies a profound truth. The more we learn, the less we realize we truly understand. And so, the next eyes on the cosmos are already being prepared. New telescopes on Earth and in space, more powerful than ever, will search deeper, probe further, and peel back the layers of time. They will test whether this black hole is a rare exception, or the first glimpse of a hidden population waiting to rewrite our textbooks. But perhaps the most humbling revelation is that the universe is not obligated to follow our rules. Its imagination surpasses our models, its creativity outruns our equations. We stand as curious witnesses, watching a story unfold that began long before us and will continue long after. In the glow of distant galaxies and the silence of interstellar space, one truth echoes: the universe is beyond our imagination. Every discovery, no matter how unsettling, is a reminder that we are part of something vast, mysterious, and unfinished. And as we gaze upward, the question lingers: what other secrets lie waiting in the dark?